Hello, welcome to the YouTube channel Physics Theories and Numericals, where we are providing you high quality videos for easy and joyful understanding of physics theories and concepts for life. Also welcome to the Easy Solution series videos for ICSE Class 10 Physics, where we are providing you solution to the numericals given in Concise Physics. Selina publishes the most read book in ICSE. This video is for current electricity chapter 8C. First, let us say the formula you have to use. That is formula for power and energy. Electric power is work done by time, that is energy by time, that is volt into ampere, that is V into I, that is V square by R, that is equal to I square R. You may require you need to pick up the right relation depending on the quantities that are available and the one you need to find out. Second, electric energy, that is work done, is equal to Q into V. This is VIT, this is I square RT, that is V square T by R. Another set is heat energy generated, that is I square RT joule or 0.024 I square RT in calorie. Then energy in kilowatt hour, that is power into time in hour, and in other different forms, right? Then cost of electric energy is electric energy consumed in kilowatt hour multiplied by cost of energy per kilowatt hour. The first numerical: an electric bulb of resistance 500 ohm draws current of 0.4 ampere from the source. Calculate the power of the bulb and potential difference at its ends. The solution: look at the formula that we will be using. Resistance R is given, that is 500 ohm. Current has been given 0.4 ampere. So electric power is I square into R. Put the values, you get the value as 80 watt. Again, for the next one, resistance is given, that is 500 ohm. Current is 0.4. So potential difference will be as per Ohm's law, that is V is equal to I into R, that is 200 volt. Next one, a current of 2 ampere passed through a coil of resistance 75 ohm for 2 minutes. How much heat energy is produced? How much charge is passed through the resistance? Simple formula. What is given is I is equal to 2 ampere, resistance is 75 ohm, time is given, that is 120 seconds. So heat energy, you put the values in the formula, you get the value as 36000 J. You have to calculate the charge. Charge is Q is equal to I into T, that is 2 into 120, that is 240 coulomb. Next numerical: calculate the current through a 60 watt lamp rated for 250 volt. If the line voltage falls to 200 volt, how is the power consumed by the lamp will be affected? This is the solution. Again, simple formula. This is the first method. What has been given? Power 60 watt, voltage has been given, current is P by V, that is 6 by 250, that is 0.24 ampere. Also we know power is V square by R, you put the values. So you get the value of R as V square by P, that is 250 into 250 by 60. So you got the resistance. Now if the voltage changes to say V dash, it is 250 volt. So new power will be P dash will be V dash square by R. So that will be 200 by 200, that is V dash into V dash by the resistance that you got. So it is becoming 200 into 200 into 60 by 250 into 250. So you do the calculation. So the power you get is 38.4 watt. So the power consumed will be reduced to 38.4 watt from 60 watt. Now method 2. What it says, power is V square by R. So power is proportional to V square. That means if the voltage is doubled, power will be 4 times. If the voltage is halved, power will be 1/4 times. So here you have to say by how much fraction this voltage is changing. So new voltage is 200 by 250, that means 0.8 times. So new power will be 0.8 into 0.8, that is 0.64 times. So new power will be 60 into 0.64, that is 38.4 watt. Next one, an electric bulb rated 100 watt, 250 volt. How much current will the bulb draw if it is connected to 250 volt supply? Simplest, you got the formula. Put the values. Just have a look. Very simple. Next one. An electric bulb rated 200 volt, 100 watt. What is its resistance? What safe current can be passed through it? Again, simple formula. Put the values. Have a look. Get the answer. No need for me to read it out. Next one. A bulb of power 40 watt is used for 12.5 hours each day for 30 days. Calculate the electric energy consumed. Look at the solution. Simplest. There is no complexity. Straight away put the values. Physics numerical is formula. You need to put the values in the formula, handle the units, get the answer. Next one. An electric press is rated 750 watt, 230 volt. Calculate electric energy consumed by the press in 16 hours. Child's play. Just put the values in the formula. Energy is power into time. Values are given, just multiply. Next one. An electrical appliance having resistance of 200 ohm is operated at 200 volt. Find, calculate the energy consumed by the appliance in 5 minutes in joule in kWh. Very simple. Again, formula. You may have to use more than one formula. Values are given, resistance, voltage, time, everything is given. You calculate power. Power is V square T by R. That is energy. Power is V square by R. That you multiply that with time, that will give you energy. Put the values, get the answer. Now power is 200 into 200 by 200. That is power. Why? Your voltage is 200 and resistance also is 200. V square by R. So power is 200 watt. That is 0.2 kilowatt. Time has been given. You multiply. You find how much energy has been consumed in kilowatt hour. Next one. A bulb rated 12 volt 24 watt operates on a 12 volt battery. Find for 20 minutes. Calculate the current flowing through it and energy consumed. Straight away formula. Nothing much to work. Easiest numericals. Right application of formula. Next one. A current of 0.2 ampere flows through a wire whose ends are at a potential difference of 15 volt. Calculate the resistance of the wire and heat energy produced in 1 minute. Child's play. Straight formula. There is nothing in it. Next one. What is the resistance under normal working condition of an electric lamp rated 240 volt 60 watt? If two such lamps are connected in series across 240 volt mains, then explain why each one appears less bright. Let's look at the solution. Again, simple calculation using the formula. You can find out the resistance as V square by P, that is 240 into 240 by 60, that is 960 ohm is the resistance of each bulb. Now, you know power is I square into R. Now, if the two lamps are connected in series, that means resistance will become double, current will become half. If current becomes half, then power will be 1/4 times. So for both the bulbs, power will be 1/4 times. Get the concept clear. If the bulbs are connected in parallel, both of them get their full voltage and glow with full power. But if the bulbs are connected in series, you need to find out the current in it and use the formula P is equal to I square R. Get the concept clear. Okay, these are easy numericals. Get your concept strong. Right? Hope you are liking this video. Please subscribe to the channel, like, share and comment on the video and press the bell icon. Next one coming. Two bulbs rated 60 watt 220 volt and 60 watt 110 volt respectively. You calculate the ratio of the resistances. Nothing. Put the formula and get the ratio. Resistance R1 is 220 into 220 by 60. R2 will be 110 by 60. You put them in ratio. You get 4:1 as the answer. Next one. An electric bulb is rated 250 watt 230 volt. Calculate the energy consumed in 1 hour and the time in which the bulb will consume this much of energy when connected to 230 volt mains. This is the answer. Simple formula. Simple formula, nothing in it. No point reading it through. Put the values, get the answers. Next one. Three heaters each rated 250 watt and 100 volt are connected in parallel to 100 volt supply. Calculate total current drawn, the resistance of each heater and energy supplied in kilowatt hour to the three heaters in 5 hours. Simple calculation formula, then arithmetic plus minus. You got the formula, power has been given, voltage has been given. So current is power by voltage, you get the current. So total current will be for 3 heaters, 3 into 2.5, that is 7.5 ampere. Resistance is V square by P. Put the values, calculate, get the values. 400 ohm. Now the energy supplied to 3 in 5 hours, that means 3 into power into time. 3 into what is the power? 250 watt. And what is the time? That is 5 hour. That means 3 into 250 into 5, that is 3750 watt hour divided by 1000. So you get 3.75 kilowatt hour. Next one. A bulb is connected to a battery of potential difference 4 volt and internal resistance 2.5 ohm. A steady current of 0.5 ampere flows through the circuit. Calculate the total energy supplied by the battery in 10 minutes, resistance of the bulb and energy dissipated. This is more like your 8B exercise numerical. Okay, let's see. This is the formula that we will be using. The solution is voltage has been given, current has been given. So energy supplied in 10 minutes. So that is power into time, that is voltage into current into time. Put the values, calculate. It is 1200 joule. Total resistance of the circuit, that is 4 volt by 0.5 ampere, because current has been told. So total resistance in the circuit is 8 ohm, out of which internal resistance of the battery is 2.5 ohm. That means resistance of the bulb will be 8 minus 2.5, that is 5.5 ohm. And energy dissipated in the bulb, that is I square into R into T. You have got the R, you have got I, you have got T. Put the values, calculate, got the answer. Easiest numericals, right? Next one. Two resistors A and B connected. A and B of resistances 4 ohm and 6 ohm respectively are connected in parallel. The combination is connected across a 6-volt battery of negligible resistance. Calculate the power supplied by the battery and the power dissipated in each resistor. Let's look at the solution. First, understand the circuit. This is the circuit diagram. 6-volt battery, two resistances in parallel, A and B. So again, simple formula. Now here you see both the resistances are getting 6 volt across the terminals. So power in resistor A will be V square by A, that is 6 into 6 by A is 4. So 36 by 4, that will be 9 watt. Power in resistor A is 9 watt. Similarly, power in resistor B will be 6 watt. Total power is PA plus PB, 9 plus 6, 15. Simplest. Next numerical. A battery of e.m.f 15 volt and internal resistance 2 ohm is connected to two resistors. Now again 4 ohm and 6 ohm joined in series. Find the electrical energy spent in 6 ohm resistor. Look at the solution. Understand the circuit. Very simple circuit, series resistance. So total resistance is 2 plus 4 plus 6, that is 12 ohm. Find the current. So current is 1.25 ampere. Now energy spent in 6 ohm resistor will be I square RT. Put the values, multiply, get the answer. Next one. Water in an electric kettle connected to a 220 volt supply takes 5 minutes to reach the boiling point. How long will it take if the supply voltage falls to 200 volt? Let's look at the solution. Formula is there, but H value has not been given. You don't require that. But same H has to be produced. So we'll go by ratio. So we know H is equal to I square RT, that is V square by R into T. Now if voltage becomes half, I will be half and H will be 1 by 4 times. So time required to boil the same water will be 4 times. It's basically ratio. If voltage becomes half, current will become half, energy produced will become half, 1/4. That means it will take 4 hours, 4 times to give you the same energy to do the same boiling of water. Now in this case, V becomes 200 by 220 times, that means 10 by 11 times. So time required will be reverse reciprocal of square of that much times. So time required will be 5 minutes into 11 by 10 and square of that. That is 300 seconds into 11 into 11 by 10 into 10. We put the values, do the calculation. So what we get is 363 seconds. That means 6 minutes 3 seconds. Now if you make this 3 seconds in decimal, it becomes 0.05 minutes. So total it becomes 6.05 minutes. Next numerical. An electric toaster draws 8 ampere in a circuit with source voltage 220 volt. It is used for 2 hours. Find the cost of operating the toaster if the cost of electricity is given. Again, simplest. Put the values, calculate. Simple multiplication, nothing in it. You need to pick up the right formula, put the values, do the calculation. Next one. An electric iron rated this If the iron is used for 3 hours daily, find the cost of running for 1 week if the cost of electricity is given. Again, simplest, nothing in it. Pick up the formula, put the values, get the answer. Next one, last one for this exercise. A geyser is rated 1500 watt and 250 volt. The geyser is connected to 250 volt mains. Calculate the current drawn. Easiest. The energy consumed in 50 hours. Again, easiest. Cost of electricity. Again, the same thing. Again, pick up the formula, put the values, get the answer. So easy these numericals are. Hope you liked the video. These difficult looking numericals, now you find it so easy to handle, right? So please subscribe to the channel, like, share and comment on the video and press the bell icon. Thank you for watching this video. We will come up with the solution for the subsequent chapters also. Be in touch. Bye bye.